Doing a little maintenance issue on the Integrex today. This is Monday. On Friday, I was checking some things here on the machine with the test bar. I'll show you that in a second. And this machine, the B-axis here, and then when it indexes down to different angles, you want this to be consistent. And right in this area, you want it to be, of course, horizontal. And then when it's at 90, you want it to be vertical. Now this machine was built in the year 2006, and here we're in the year 2020, so it's 14 years old already, this machine. And you get a machine like this. Now I bought the machine used, and I don't know what happened to the machine before I owned it. I think I'm the second owner of this machine, but I noticed there's a big ding. Well, let me show you here if I can get over here, if I can walk over here somehow. I don't know if you can see this, but you see right there on the top of where that bolt is, or that clamp screw is on the tailstock, there's a big huge ding in that, which says to me somebody probably ran the machine into it. So that was one thing. Now when you buy a piece of used equipment, it's a good thing to possibly do some tests on it if the person selling it will allow you to do that. I didn't do it in this case because I didn't have some of this stuff to do it with, but when I got this machine and set it up and leveled it out, it wasn't square on this B-axis anyway, and so I had to align it. Now in order to do this, this is a job that's kind of like, I put it off if I can for any reason whatsoever because I hate doing this job, but you have to take all of these way covers. Here's the sheet metal, and you have to disassemble this and take this out because you cannot get to these bolts. See, what you're looking at is, see all these big fasteners around this coupling around the B-axis. You have to loosen them and then snug them back up, and you see that adjustment mechanism up there. You have to kind of adjust this. And I'll show you this. We're going to go through it here to get the thing to run true. So what do you need to do this is you need, for the case of this, you have this test. In this case, this machine has a Capto spindle. So you got this Capto test bar here. And you're going to put it in the spindle, right? Clamp it in here. And this test bar, you can indicate up and down, and it's made precisely. There's even a data sheet that comes with it. This is a Sandvik test bar, and it gives you the actual the required tolerances and the actual tolerances of the test bar when it was manufactured. And hopefully it's still that way. So I can indicate this back and forth and get the machine to run true as I can. And like I started to say earlier, this machine's an old machine, and it's not going to be perfect. This is something that you got to be aware of when you're buying and using equipment that's not like brand new. So what we're going to do here is we're going to indicate along this in the horizontal axis. Like right now you see the B is at 0, and this is the home position, or the zero return position of the B axis on this machine. So what we want to do is run this up onto the indicator and run it up and down and see where we're at. Right? So let's just get this thing, we're going to get the high spot of this test bar, which is right there. So we'd be on center line. I'm going to back this off so we don't over travel our indicator. We're going to set it on 0 right there. Now you can see this is a 0.5 thousandths per line indicator, or inter-rapid indicator. So if I run this all the way up here, I can see I'm out about a 0.5 thousandth on the length of that. But you gotta kind of check this in different ways here, because this isn't really the actual. I'm going to unclamp the spindle so I can rotate the test bar. You can see there's a little bit of run out in this spindle. Now we're way out here on the end of this test bar. Here, where they tested it, they said that this thing actually ran out. This test bar actually runs out, if I calculate it into inches, about 2/10,000ths. So, which is apparently within their spec. So we got to take that into account. And you can see right here, I'm getting about a 1/2,000th run out in the test bar itself. And I can clamp this in 3 different positions in this cap toe taper, and we could also look at that. But so you have to kind of take that into account here. So I'm going to kind of put it in the middle of that run out here if I can, and we're going to see what we're doing here as far as actual so it's a little bit less than 1/1000th of an inch, and it is tipping because this indicator is getting higher this direction as the needle sweeps this direction. It's actually falling away upward from the indicator. So that's in the horizontal direction, which, I mean, I could almost live with that. That's not that bad. But as I said, this is an old machine, and things are not perfect, and you can't get them perfect. You got to understand this about some machinery, and you got to get it good enough to where it works for you. That's the only way I can put it, I guess. So let me indicate this thing the other direction, but I have to reposition everything. Just up to 0 on the indicator. First we're going to go up to the top of the bar, and you're probably going to see more deflection this way than you did. I don't want to run the indicator into the top here. See up here, might be dirt on there or something. See, up here there's very little run out on this test bar. I'm going to bring it back to 0. I'm going to jog it. Something's bring that back to 0 again. Something's weird with this. Maybe my indicator has got a loose stylus on it or something. I have to check that. But you see here, we're running down, up and down with the B at 90. And to be fair, let's go in the middle of this run out, which is around there somewhere. Let me go back down. You see, I'm at 0, and here I'm like 2/1000ths, around 2/1000ths. And this here again, this is pushing into the indicator, so it's this way. So remember, when we were horizontal, it was tipped up this way a little bit as well. So if we can, the best thing we can do here is to average out these errors, because this machine, I don't know, somebody might have run into something or something. It's always been this way. It's not something new, but when this gets to be this much, it can cause me a little bit of a problem. If you can think about this with a boring head, and most of the tools are about this long, so you're out here and you're running at an angle in relation to your actual travel, and it can cause you problems if you're trying to hold, less than 1/1000th of an inch. This could cause problems. Now you can see how much little effort I can pull this thing. So every tool has flexes when it runs, or if it's running slightly out of balance, it's not going to run true either. So there's all these errors that come into play when you're machining, and you can never, although it would be ideal for the machine to be perfect, no machine actually really is in reality. So what I got to do is, I showed you all these big screws around here, and the ones on this side, you might be able to see them there. I've got to loosen all this and snug it all back up a little bit, and then I've got to try to adjust this thing with the adjustment screws up there, which are these right here, and this will move it. You know, they're kind of like jack screws, and you can jack it back and forth very small amounts. It only takes, as you see, a very little amount. Here, let's look in here a little bit and see what this looks like, because I've had people ask questions about this, and what's when I made a mention on the I think it was an Instagram post about the liquid cooled lead screws. Let me see if I can get a flashlight. Let's see if you can see this. You see this tube right here, this right here, this one, and then back there, I don't know if you can see back there, right back in here, that's the pipes that come into the lead screws, and then there's a hole through the middle of the lead screw, and it circulates oil. I don't know if you can see the one, no, you really can't see back there, but the y-axis lead screw, which is what this one is, they pick the oil back up and it goes through the chilling unit. So they actually, these lead screws are actually liquid cooled. I don't know if you can visualize, see I got my hand around the lead screw here now. So what's this about? I don't know, a little over, maybe about 2 1/4 inch diameter, and I don't know what that lead is, but you know, from here to here, I don't know, maybe about 10-12 millimeter lead. Not sure what the actual lead is. You can see the, I don't know, let me get the light up here and see if you can see the bearings, the linear bearings. There's the y-axis ones, and the size of this this linear slide. You see this about 2 1/2 inches wide, roughly, whatever that is in millimeters. So the slideways on the y and the x-axis are about that size. Can't see from here, but the z-axis ones are maybe, I don't know if they're the same or a little bit larger. And these bearing packs are pretty good length. Maybe they're about 8 or 10 inches long. I don't know if you can see back there or not. And this right here would be the balancing cylinder that balances out the x-axis, attaches here, and it goes up through there to this cylinder. I think it's a nitrogen cylinder that balances the x-axis, although it doesn't really take all the weight off of it. If you look on the display here, on the control, you can see that it's it always sits here with about 40-something% of x-axis load, but that's normal for this machine. It's always done that. That's just the normal way it works. Why don't we go in the back here and look while we're looking at the machine when it's open. Turn the light on here. This is the cable management in the machine, to give you an idea how big this is. Right here, it goes around like that. There's the z-axis ball screw. See if I can climb in here without falling down and slipping on. There's tons of oil. Ooh. There's tons of oil on here, so I gotta be careful. It's like whey oil. Okay, so we're inside the machine here. You just saw out there, if you remember, right here, where the X and the Y axis was. And this is the Z axis lead screw. I'll kind of give you an idea of the size of this. And that's me holding on to it with my hand. I'd say that's about 3 inches in diameter. And it's got 1, 2, 3 slideways for the Z-axis. Here's the bearing pack. See, it's got 1, 2, 3 on the y-axis, and also 1, 2, 3 bearing packs on the x-axis for that. So here again on this lead screw, see right here, see that pipe right there? That's where the coolant comes in. It goes down that lead screw all the way to the end, and then it comes back. Maybe you can see the chiller from here. You can kind of see part of it right there. Maybe if I extend this thing, that's where the chiller is. It's kind of on the other side of the headstock. And then this little chiller here is for the spindle, the oil that circulates through the spindle. And there's the Z-axis servo motor. And here's all the, I don't know if you can see any of this. This is all the plumbing, hydraulics, and pneumatics, and everything that comes up to the V-axis. And all goes through there. This is, if you look at the manual, this is awfully complicated. All of this, there's like a swivel that runs all these fluids into the B-axis. You can see how many lines are coming over here. And they come up here and then come all the way through all this stuff here, all the way over there. So that's just a little look inside the machine here. Oh, by the way, those of you that are making your own machines, you see how they do the way covers here? They have these kind of I don't know what you call these things, these expanding zigzag things. They have it at the top here and the bottom of these long way covers so that they don't get out of alignment with each other. They also have little ones. They're collapsed right now, but you can see them right there. And at the bottom here, if I can get some light in there, they're collapsed right now, but this is the way you can make your way covers and they don't get out of alignment, and then they get in a jam and get all bent up and everything. And this system works fine. So when those things open and close, they keep them evenly spaced at the top and the bottom, or on the sides if it's like these little ones over here, and keeps everything running straight. So that's the way you do it. And this machine rapids at 1,600 inches a minute, so these things would really have a problem if they didn't put those things on there. I at least want to get this to 0. I don't know if I could put this, let me see something here. I'm going to move this around a little bit. Let's see if I can put the indicator to where we can see it. Get down here. Zero there. Zero. Kind of go halfway in the run out and check it back up here again. Should be zero. There's virtually no. See, there's no run out down here. I'm gonna check this dial indicator. I think there's something loose on here. Okay, let's run down here. This thing kind of jerks around because I'm jogging it at the maximum hand wheel jog, and it kind of jerks around a little bit. I think my stylus was a little bit loose on the dial indicator. Okay, see, we got almost 1/1000th of an inch run out, so I'm gonna go in the middle of that. The run out down here is virtually zero up here on this test bar, so I think, well, according to the data sheet from the gauge line out 230 millimeters, I should have said earlier, there, even on the specs of this, there was 2/10 run out, but the spindle must have a little bit of run out when you get way out here. This is just the nature of, like I say, a used machine, really. So, I don't know, maybe there's a piece of dirt on here, a scratch or something. Grease. Probably ought to wipe this thing off. My hands are kind of greasy as well, dealing with this machine, and I've probably got some kind of grease on this test bar. Alright. Now, like I said, I'm going to half that run out. So I still got to come down a little bit. This thing really isn't moving very easy though. And I can't see what I'm doing. I don't know, they should have made this bracket a little stronger for this adjustment mechanism, because it just literally bends it. What we're going to have to try to do is average out the error between 90 degrees and 0 degrees, because it, like I say, it really just can't be absolutely perfect on this machine. So I'm going to go a little bit beyond. So that means the bar, if I push up and down on it, down is this way. I don't know if you can see me doing that. Yeah. You can see I can deflect it a little bit. So I want to actually be a little bit down in this plane, and then let me index things to the 90 degrees here. Touch. Go back and forth in Y a little bit. Get my high spot. I'm going to run up to 0 here in the Z. Hopefully this won't run out too much. I went just a few tenths beyond where I wanted to go. Okay, see now I've cut the air in half. See what the run out is doing here. Okay, that's about right in the middle of the run out. So I cut the air in half. So that's 1/1000th of an inch across the whole full length of this test bar. It's not too bad. But see, I'd like to actually go a little further in the horizontal direction downward. So I pull this back just a little bit so that if I can get both of them out, maybe about less than 1/1000th, maybe a 1/2,000th. If I go a 1/2,000th more down there, then maybe I'll just be a 1/2,000th here, and that's about the best it can be. You know, it just can't be perfect. It's this kind of a thing, you know, where you just can't get everything perfect because it's an old machine and it's going to be what it is. Now if I bring this up maybe a 1/2,000th this way, I know it's not perfect, but can't get it perfect, like I said. Let me see. I don't know if you can see what I'm doing over here. I'm adjusting these screws here. I'm trying to watch the indicator at the same time. Well, actually, backing that one off put me about right. I backed off the one that was tightening against. Go a little bit more like that. Snug the clamp screw back up. All right. Doesn't look too bad. I'm about a 1/2,000th, not quite a 1/2,000th. And say the reason this needle jumps around, if I jog it roughly, it actually wiggles the needle a lot. If I try to keep it smooth, it's kind of hard with I'm jogging the hand wheel at the maximum jog rate, and it kind of jerks around. See, if I do it smoothly, the needle stays a little still, a little steadier, I should say. Okay, now, so this is the downward direction. If I push down, it's going that way. So this is tilting down just a little bit. And this might not be a bad way to be, because when you're pushing with a drill, it's probably going to naturally pull upward a little, you know, and force the force of because the feed of the Z-axis is down. You can see where I'm pointing is actually down below where this is, the spindle is. It'll actually tend to raise up with force like this, so that might be all right. Now if I'm less than 1/1000th in the vertical direction, I think I'm going to leave it alone and tighten all the screws and then check it again. Put it down, see what happens here. Okay, see, we got almost about the same error in both directions now. So I can't really go any further in the one direction without, see, because this at 90 degrees is pushing towards the indicator, and remember it was on the other side of 0 and falling away. Let's orient the spindle. That's oriented. And here's clamp. See, it really doesn't move at all close to the spindle. Unclamp. Orient 180. Clamp. Wow, it moves a lot there. 180 degrees it moves. Unclamp. Orient normal, clamp, it's back to 0. Unclamp, orient 180, and clamp. That's interesting. That's let's see what it looks like all the way down here, oriented 180. Still got about the same amount of deviation, even though it shifted it a little bit. That's interesting. I never had checked that before. Let's go back to 0. We'll run down to the end of the bar. Still got, well, we still got a little bit more than about 8 or 9 tenths of a thousand at the clamped 180 degrees. Unclamp, orient normal, clamp, and see it moves quite a bit, doesn't it? This really won't matter for milling aspect because it's just turning tools, and you can adjust those with offsets. It looks a little bit straighter at the normal orientation, a little bit. That's interesting. But anyway, let me tighten up all the screws here and then see what we got. I don't like the way that looks already. Run it back out. Let me check where we are in the run out wise here. It's about the middle of the run out. It's about on 1,000. Right around there. Re-zero it. Apparently something is changing a little bit. Just a little bit more than a half a, might be about 7 or 8 10,000ths. And like I said, I would rather have it like that in this mode, because as you push on the spindle, it'll tend to go up, it'll tend to, because the drive of the Z-axis is way down there. I don't know if you can see where I'm pointing. Way down underneath here, and this is up above it. Even when you're on center line, you're probably 18 inches or more above where the actual ball nut is for the Z-axis. So it's going to tend to want to push the spindle upward in the horizontal mode this way when you put force on it. And so that would be if you got to have error, that would be the best way to go with it. So let me go to the 90 degree. Run up and down here. Okay, up in X. About 1,000. See what we got run out wise. I'm going to try to split the run out there. So it's about 6 or 7 10,000. So it's about the same. So that's as good as it's going to get. And I got the bolts tight. So now all I got to do is button everything back up. This is just kind of a thing you have to do. Now I have to take those and put that all back together. That's the worst part of this job, really, to do all that and get that all buttoned up, and we should be as good as we can be now. Unfortunately, I can't get it perfect, but the machine has never been any better than that, so that's the way it is. With an old machine, you just got to deal with these things.